exercise related to the image formed by a convex lens. How image can be formed by a convex lens. Different questions are there from the past papers. In the first question, figure 6.1 is a full-scale diagram showing a converging lens with two principal focuses, f1 and f2. And an object PO is there. You can see this is an object. Okay. On a figure, draw two rays from point O of an object to determine the position of an image and label that as IJ and measure the length of image. So first, here is an object. So just follow the rule. We always draw from a tip of an object first. From a tip of an object, we'll draw a parallel light ray. From where it will pass through? F1. So it will pass through F1. Okay. The second one, which light ray? What should be the second light ray? So it will pass through the focus. It should pass through the center of the lens. It will pass straight. Then one mark is for drawing an eye. It's important that you draw an eye. So because without an eye, you won't be able to detect this image. So if this is a lens, this is an eye here, what will happen? Our brain produce, imagine that the light is coming straight from the object. So when it create, this will be the new position. And that's how the image will be formed. And we have to label that as IJ. So this one will be I and the other will be J. Okay. And then the next part is you have to measure the next part is image length. You have to measure this length of an image according to the scale, because this is not done or not to the scale. Now use a screen annotation, 3 description of the image. Which are the 3 description of the image? You can annotate on the screen the 3 description. Yes. Magnified is one. Virtual. Good. What about the third description? Because we have to, so it is same way up. This is not a real image because real images cannot be formed on the same side. Real images are always inverted. This is formed by the imagination. So it's a virtual. So it is magnified. It is same way up and it is virtual as well. I'll share this exercise so you can practice after the session. Next question. Figure 7.1 shows a converging lens and the image formed when an object is placed to the left of the lens. The principal focuses are labeled as A and B, and the center of the lens is labeled as C. On the figure, draw 2 rays to locate the position of an object. So first ray, look, this image is given. Now we need an object. But you can do the same thing. You can locate the object from the image. You can locate the image from the object. Use the same idea. Well, the idea remains the same. If there is a parallel light ray, from where it will pass? If the light ray is parallel, here image is given to us. If a light ray is parallel, so from where it will pass? It will pass through A. And one through the center will pass straight. The point, the position where the 2 light rays will meet, that will be the position of image. But this time we have the image, so we are locating an object. So how we label? We label that as O. So actually what happened? First, a light passing through the center of the lens will pass straight. One through the focus will go parallel, and the 2 light rays will meet or intersect, and that is the position of an image. The next is, which distances are equal to focal length? Which distances? You can annotate on the screen which distances are equal to focal length. What are the distances equal to focal length? A and C, right? And C and B. So I'll share another link, join from the link